Hey guys, Mrs. Thompson here, and today we're going to talk about binary ionic compounds. That word binary is just referring to the fact that we're only looking at ionic compounds that have two elements, a metal plus a nonmetal. Okay, just to remind you here about the charges on the periodic table. Remember that those are 1 plus, 2 plus, 3A's, 3 plus, and we don't really talk about 4A. Then it goes the opposite direction, 3 minus, 2 minus, 1 minus, and then 0 for noble gases. Here are steps for making compounds. We're going to start this way. We're going to try to figure out how we can balance the charge. When we do this, our charges always have to add up to 0. We'll add subscripts to show how many ions it takes for this to happen. And then we'll write the cation first and the anion second. What it's going to look like is going to be a little bit different than this. But this is what you're trying to imagine, that each time we have the valence electrons being donated, or one gives up, the other one takes. They're being transferred from the metal to the nonmetal. And the result is the formation of an ion. Sodium positive here and chlorine minus there. And when we bring those together, these two charges cancel each other out. This positive charge cancels this negative charge to give you an overall charge of 0. So we'll do strontium and fluorine. First thing we need to know is what column they're in on the periodic table, and that would give us the charge that they're going to be. So since strontium is in group 2A and fluorine is in group 7A, we can figure out their charges. And then I'm just going to write them next to each other just to see what they would look like with their charges. Now, we're trying to get an overall charge of 0. When I add these two together right now, they would add up to be plus 1. That's plus 2, and 1 minus added together would give me 1 plus. So what we're going to do is we're going to add more of either the positive or the negative so that we can get to that 0, that overall charge of 0. Since I have more positive than negative, I'll add another fluorine. And now that's 2 plus and 2 negative. Overall, when we add those together, it'll be a total of 0, and it'll cancel out these charges. And so I'll write the formula by stating how many of each we have. I have 1 strontium and 2 fluorines. 1, 2. And so the little subscript is just telling me that's an overall charge of 0. That's what that's for. The subscript is just telling me how many of those fluoride ions I need for 1 strontium. That just means that strontium has 2 valence electrons to give up, and it's going to take 2 fluorines to accept those valence electrons. Okay, we'll look at calcium and phosphorus. Calcium is in group 2A, so it's a 2 plus. Phosphorus is in group 5A, so it's a 3 minus. And so we're just going to keep adding until we get an overall charge of 0. Looking at this, I have more negative than I have positive. And so I'm going to keep adding more positive, which is the calcium. Now I can't just add calcium with a 1 plus charge because that's not how calcium comes. It comes as a 2 minus charge. Excuse me, 2 positive charge. So there we go. We'll add another calcium, and you can see that now we have 4 plus and 3 minus. And that isn't quite canceled, so let's add more negative. Well, that doesn't work. Now I have 4 plus and 6 minus. Well, it seems like it's going to take us forever, but look, if we do this just one more time, we add another calcium, you get an overall charge of 6 plus and on the left and 6 minus on the right, and those 6 positives cancel out those 6 negatives. It's kind of like you're finding the least common multiple. What will 2 and 3 go in? And both of them will go into 6. And so how do I get that 6? Well, it's going to take 3 calciums and 2 phosphorus. And so here's my formula between these two ions. I have this 3:2 ratio. Okay, next we're going to learn how to name binary ionic compounds. Anytime you're naming an ionic compound, you have to name the cation first. And the cations are going to be, for just binary compounds, a metal. So you name the metal first. You don't change the name of the metal at all. It's just the metal's name. However, if it is a transition metal, that's one of the metals that have multiple charges. What we're going to use is we're going to use a Roman numeral to show what charge that metal is. For example, iron comes in iron 2 and iron 3. So if we have iron with Roman numeral 2, that means we're referring to iron 2+. After that, we'll name the anion. For the anion, those come in two forms. Monatomic, which is just one atom. Those are the ones on the periodic table to the right of the staircase. We'll change those endings to IDE. So chlorine will change to chloride, oxygen to oxide, sulfur to sulfide, and so on. If it's a polyatomic ion, that name ending is going to stay the same, and we'll get to those when we do next set of notes. Okay, this is just a little hint here. To determine which is the cation and which is the anion, it's helpful to draw a line after the cation, which is a metal, or it could be ammonium. And so that just separates cation from anion. Name cation first, the anion second. So let's do these three examples. We have calcium as our metal, so I'll draw a line after calcium. I know that calcium, capital C, lowercase a, is the first element. And so we'll name calcium, and then the anion would be chlorine. We'll change the ending of the anion and call it calcium chloride. Second one, we've got Na is our first element. So the cation is sodium. Don't do anything to it. Not a transition metal. And then we have bromine, so we'll change it to bromide. Third one, we have potassium over there on the left side of that line. And nitrogen, we'll change that to nitride. So that'll be potassium nitride. Notice I'm not keeping track of how many of each atom I have. I'm only simply stating the metal and then the nonmetal. All right, next we'll take a name and change it into a formula, just something we did earlier, but let's do it again. Here we have potassium chloride. Now potassium is in the 1A column, so it's 1+. Chloride was originally chlorine. Now when you see the IDE ending, think, okay, that is a monatomic ion. I'll look at the nonmetals and see which one it is. So chlorine is a 1-. Bring those two together. We just need one of each, so it's just KCl. Next one, magnesium sulfide. So magnesium is magnesium with a 2+ charge because it's in group 2A. Sulfide, well, that must have been sulfur. So sulfur is a 2- charge. Looks like if I just use one of each, they would cancel the charge. So we just need NGS. Okay, aluminum oxide. Aluminum is in group 3A. It's a 3+. Oxygen in 6A. That's a 2-. Okay, so let's try that trick with figuring out the least common multiple. So 3 and 2 again. Least common multiple is 6. So we'll need 2 aluminums to get an overall charge of 6. And 3 oxygens to get an overall charge of 6-. And that just turns out to be Al2O3. 2 aluminums, 3 oxygens. All right. Next, we need to look at what to do if it is a transition metal. So what if I have multiple charges? So this is when we use those Roman numerals I was talking about. They're only used if the metal has more than one possible charge. So we need to use our periodic chart of charges. Do not use Roman numerals for single charge transition metals. And so the ones that you have to remember are always single charge are the transition metals in the magic triangle. And so even though silver is in the transition metal area, because it's in the magic triangle, we're not going to use Roman numerals. So it would be, this one would be silver chloride and not silver Roman numeral 1 chloride, just silver chloride. Okay, here are the Roman numerals. So in case you haven't used them before, you might want to write these down. V is for 5. If you put a 1 before V, that means it's 1 before 5. That's 4. If you put a 1 after the V, then it's 1 more than V, and that's a 6, and so on. Okay, so just a reminder, the magic triangle is right here. If it is a metal in group 1A or 2A, or in the magic triangle, then it has only one charge and does not need Roman numerals. So we've got, remember, aluminum's 3+, so it's gallium and indium, zinc's 2+, cadmium's 2+, and silver's 1+. That means that all of these other transition metals, I would like you to remember to put Roman numerals with them when naming them. All right, let's try this one, writing the formula or the name. So here is iron 2 sulfide. Remember that the 2 doesn't tell me how many irons. Careful that you don't think that. The 2 means that this is iron 2+. That's reacting with the sulfur. And gold 3 oxide. So that, remember, it's iron 2 and iron 2+. So we'll put iron 2+ and sulfur 2-. Just need one of each. As soon as I bring those two together, it cancels out the charge. And we have FeS. Gold, Roman numeral 3, remember, is gold with a 3+ charge. So that's Au. And oxygen is O2-. This is another 3-2, so that means we need an overall of 6. So we'll make that happen. So that's going to be 2 golds, 3 oxygens. All right, now I have the formula. We have to name this. So it's a little trickier to name them because you have to figure out what the Roman numeral is. This could be, if you look at the chart, could be copper 1 or it could be copper 2. But let's go ahead and just figure it out based on the information we do have, which is the charge on the bromine. It says, when naming compounds with multi-charged metals, you must work backwards to determine the charge. So let's work backwards. I'm just going to rewrite what I had. Like I said before, this could be copper 1, it could be copper 2. So let's start by working backwards. Copper 1 would look like Cu+, copper 2 would be 2+. And so we have 1 copper and 2 bromines. That means that the overall charge for the bromine was 2-. So we had to figure out, what did copper by itself have to be in order to cancel out a 2- charge? Well, it had to be a 2+ charge. And so this will be copper 2, Roman numeral 2, bromine. FeO. So I have 1 iron, 1 oxygen. Oxygen I know is a 2-. And so what did iron have to be in order to cancel out that 2-? It had to be a 2+. And so if it's a 2+, that makes this iron 2. And this is iron 2 oxide. Another. Okay, so let's see. I'm going to write out as many as I have. I don't know the charge on iron because it's a transition metal. It could be more, it could be one of 2 charges. Then I have sulfur. I have 3 of them, which means that altogether sulfur had to add up to a -6, which means that my iron needs to add up to a +6. So if I have 2 irons, then what did each iron have to be? Well, they both have to be 3 in order to cancel out the sulfur. So this is iron 3 sulfide. Looks like that's it. Okay, please bring some questions to class.